Hi guys, welcome to today's lesson. Today we're going to be talking about solutions. So we had already discussed water and the properties of water, that it can be a solid, and one of the properties of water is that it is the universal solvent. So water makes a lot of solutions. So today we are going to be looking at the components and the terms associated with the solutions that water very often makes. Solutions contain two pieces. The first piece is called the solute, and the solute is the stuff. So if you were making a solution of Kool-Aid, the Kool-Aid would be the solute. If you were making a solution of chocolate milk, the chocolate sauce or the chocolate powder is the solute. It's the stuff that goes in, that gets dissolved. It's usually a solid, it's sometimes a gas, it can be a liquid, and it's usually the smaller part of the solution. So the bigger part of the solution is called the solvent. This is the dissolving medium, the thing that accepts the solute. The most common the most common solvent is water. It's called the universal solvent. And because water is the universal solvent, there's a special name for all of the things that get dissolved in water, and that name is aqueous. And when we see aqueous, remember we had that when we were balancing equations, that little symbol AQ, but also think like Aquaman. Aqueous means water. Okay, so in this picture, what we're seeing is a lot of little water molecules. Those are the red and white guys. And they are picking up these big giant spheres of solute. So in this picture, the red and white water, that's the solvent, and it is picking up and distributing the solute, which in this case is some sort of you know, ionic compound, maybe sodium chloride or something like that. So dissolving is the process of is a physical process where the solute becomes distributed among the solvent. I want this video on the process of dissolving. So these little guys, these are the water molecules. They look like little Mickey Mouse. And here they are coming up against a crystal like sodium chloride. And you can see that they come up right next to the sodium chloride, and based on their charges, the positive charges of the hydrogen and the negative of the oxygen, they're going to be attracted to the molecules. So the chlorines are blue and they're going to be negative, and the sodiums are red and they're going to be positive. So what we see is as the water molecules come up, the positive sides are going to line up with the negative sides, and then the negative sides of the water molecule are going to come in and they're going to line up with the positive molecules and pull those away. So the opposite charges of the water molecules surround the solute. So that's why water is the universal solvent. It can dissolve any compound. If the compound is positive, it puts its negative side next to it. If it's negative, it puts its positive side next to it. And so the water molecules then slowly come in and break down and carry away the water molecules. And uh, that's what makes it the universal solvent. That's what makes it able to do that. So you can see, oops, in this picture, let me go back, that the sodium here is positively charged. And so the negative of the oxygens come in next to it and carry it up and away. And on this side, the opposite, the negative chlorine, those positive hydrogens come in and they pick up the chlorine and carry it away. So we call water the universal solvent because it is able to come in and dissolve any kind of compound like this. Okay, so now we are looking at the homogeneous aqueous solution. And so this is a really important definition to talk about. Homogeneous, as a reminder, just means the same throughout. So something that's homogeneous, we expect to be the same at the top of the solution as at the very bottom of the solution. You can think about this as like every portion or every pour. Like if I were to take a Kool-Aid or a chocolate milk and I was going to pour it, into different cups, that every cup would be equal. If you know that one cup maybe has more chocolate for the chocolate milk than another cup, then that is not homogeneous. That would be called heterogeneous. Aqueous means that water is the solvent, and a solution means that the solute has become fully dispersed in the solvent. And it also indicates that the solute particles are too small to see and that they can pass through a filter paper. So when we think of a homogeneous aqueous solution, we want to be thinking of Kool-Aid. Okay, Kool-Aid is a perfect way to think about this. If you make a solution of Kool-Aid and you really stir it up until it gets completely dissolved, it will be the same throughout. It used water as the solvent, and that solution, if you were to pour it through a coffee filter, say, you would expect that the entire solution, the solute and the solvent, they would both come through the filter paper. And so that's the indication that it is a homogeneous aqueous solution, which is an important distinction in chemistry. So depending on the conditions, it may take more or less time to dissolve something. How fast a solute dissolves is called its rate, or its rate of dissolution, or its solvation rate. And there are three ways that we can change the rate of dissolution. One way is that we can stir it. One way is that we can increase the surface area of the solute. And the last way is that we can heat it up. And so I want you to think about these things as ways where you can make something dissolve faster. If you're making hot chocolate, for example, from powder, when you put that hot chocolate in, there's a few things you're going to do. You're going to want it to be going into hot water, right? Because that will dissolve better. You're going to stir it or agitate it in some way. And if you find little chunks in the hot chocolate as you pour it in, you're going to try to like smush those against the container walls, getting the water all the way in contact with the solvent, and that's, or the solute. That's going to be the really important thing. So one thing that we can do, like we mentioned, is heat the solvent. A higher temperature means higher energy, which makes the molecules move faster. We already know about this, right? We've talked about this with gases. If we can heat it up, then we're going to make them stronger and faster at doing their job. And so the job's going to get completed faster. The second thing we could do is we can increase the surface area of the solute. So in this case, instead of like one big sugar crystal or one big like bath bomb chunk, what we want to do is we want to crush it up. And as we crush it up, we increase the surface area, and that allows more access points for the solvent to get in and touch the solute. And that's what's required in order for it to dissolve, is they need to come into contact. So as we crush the solute, we allow the solvent more access, and that means that it's going to be able to do the job faster. It's going to be able to dissolve it faster. The last thing that we could do is we can agitate the mixture. Once those little water molecules come in and they pick up the solvent, then they tend to just kind of hang out there. And so what we do when we mix it is we kind of move them out of the way. It's like at the snack bar, right? If you were to go up and get your food, and then once you got your food, you just waited at the front of the line, just like hanging out, talking to your friends, you're slowing down the whole process. What we need you to do is get out of the way. We need you to go so that we can get in and get access. Didn't that just make you kind of miss being at school? Remember when we used to go to the snack bar? That was cool. Okay. So the three ways that we can change the amount of time it takes to dissolve is we can speed it up, increase the rate, is we can heat the solution, more kinetic energy, more movement, more speed. We can increase the surface area of the solute, more connections, more interaction, which is going to speed it up, or we can agitate it, move those full saturated pieces of solvent away so that new ones can come in and do their job. It for today. When we discuss in the next video, we're going to be looking at the factors that change how a solvent behaves, or what happens once the solute is added to the solvent. How can we affect that solution? And so we're going to be looking at that tomorrow. As you guys are leaving today, please, please, please work on that vocab. Please know that vocab is one of the most integral things in this chapter. You need to know your vocab terms. Go over to Quizlet, practice your terms, Do that now. Get your work done so that you do well on the test. See you guys tomorrow.